So in this video, we're going to look at question B of question 5. And so it says a tungsten filament lamp consists of a long 25 centimeter filament supported at each end and in the middle. When operated using 50 Hz supply, there appear to be 4 loops in the filament. Estimate the tension in the filament given the density of tungsten is 19 grams per cubic centimeter. Okay, so first of all, you want to estimate the tension, and we are given something regarding the oscillation of a filament. So I suppose this is just a stationary wave case where both ends are fixed for the filament. So if it's a string, then we can utilize this equation. So what we know for a string is that we can say velocity is equal to the tangent over the linear density. So for the question, it wants us to estimate the tangent, and utilizing the velocity, I suppose we can link it to the equation v is equal to f lambda, and we can get both f and lambda. So the only variable in this case is tangent, and then we can calculate the linear density as well. Okay, so we have to quantify the linear density. In this case, we are only given the length and the density. So, well, for linear density, it should be equal to linear density should be equal to the density multiplied by the volume divided by length, which is basically the density multiplied by area. And we aren't given any information regarding the area. So I suppose it says estimate, so we can estimate a value for it. Okay, so we can look at the previous question probably. Over here it says a metal strip with 4 millimeters. So I suppose maybe we can just directly use 4 millimeters as an estimation for the filament. Okay, so let's see. If we utilize 4 millimeters, we should have over here the density is 19. So that should be 19, and then we have to convert to units to kilograms per meter. That should be it's 10 to the 6 over 10 to the 3rd. Right. Yeah. Okay, and then we multiply by the area. The area is 4 millimeters in width, so that should be okay, let me see. That should be 2 times 10 to the minus 2 for its radius squared pi. Yeah. Okay, now that should be done. Then we can just plug this into a calculator to get a value. So over here it says 19 multiplied by this should just be 1,000, and then multiplied by this is 10 to the minus 3 squared times pi, and that is 0.239. Okay, that is kilograms per meter, and then we can simply plug this into the equation to get a value for the tangent. So the tangent in this case, I can just squared and then multiply by the linear density. So that should be the frequency over here says 50 Hz, and then the wavelength, well, I suppose it says there's 4 loops, and then the total length is 25 centimeters. So this means that one wavelength should be half of it, which is 12.5 centimeters. So which is 0.125. And we multiply by 0.239 to get the value for this. So that should be, let's see, multiplied by 50 multiplied by 0.125, and that gives us 1.49 newtons. That should be the answer to this question.